Some companies make headlines by promising the impossible. Others quietly rewrite the rules while everyone else is still debating. Last Energy falls squarely into the latter category. On December 17, 2025, the company announced a massive $100 million Series C funding round, a clear signal that investors believe in their unconventional approach to nuclear power. What makes Last Energy different isn't a flashy reactor design or a headline-grabbing CEO. It's their radical operational strategy, building modular reactors almost entirely from off-the-shelf industrial components. Think IKEA-style nuclear power, and you start to get the picture. In the nuclear industry, custom parts are the enemy of speed. Traditional reactors are laden with bespoke valves, control rods, pumps, and piping, each designed from scratch, rigorously tested, and certified for decades of use under extreme conditions. That's why it takes years, sometimes a decade, just to get the supply chain lined up. For most nuclear startups, waiting on these components is a death sentence. Delays blow out budgets, timelines slip, and investor patience evaporates. Last Energy, however, is challenging that paradigm head-on. The company's core insight is surprisingly simple. You don't always need custom when off-the-shelf works. By sourcing standardized industrial equipment, the same types used in chemical plants, oil refineries, and conventional power plants, Last Energy can build reactor modules in months instead of years. These components are proven, certified for industrial use, and available from multiple suppliers. That redundancy and speed of access is exactly what allows Last Energy to compress timelines in an industry notorious for glacial pace. Their funding announcement highlighted just how far this strategy has taken them. The $100 million infusion isn't just about expansion, it's about execution. With capital in hand, Last Energy can scale their modular factories, stockpile components, and assemble reactor units in a factory-controlled environment. The traditional model of shipping thousands of custom parts to a site for on-the-ground assembly is being replaced by something far simpler: pre-built, quality-controlled modules that bolt together almost like furniture. It's a bold bet, and for good reason. Nuclear regulators have historically been skeptical of non-traditional approaches, especially when it comes to safety. But Last Energy's approach is engineered to be safer, not riskier. Off-the-shelf components aren't exotic for a reason. They're reliable, well understood, and in many cases over-engineered for extreme conditions. By designing reactors around these standardized parts, Last Energy minimizes unknowns, reduces failure modes, and accelerates certification processes. From an investor's perspective, this IKEA-style strategy is a dream scenario. Speed reduces capital lockup, increases visibility of milestones, and builds confidence that the first reactor units will actually produce revenue. It's no wonder they attracted such a substantial Series C round. The money isn't speculative. It's backing an operational model that could realistically deliver functioning reactors faster than anyone else in the space. Critics, of course, have questions. Can off-the-shelf industrial parts really handle the extreme conditions inside a nuclear reactor? Aren't there risks that standard components might fail under high neutron flux, radiation, or high-temperature gradients? Last Energy acknowledges these concerns, but counters with extensive engineering and testing. Their design integrates redundancy and modular isolation. If one component fails, it can be swapped or bypassed without compromising the reactor as a whole. In other words, their strategy doesn't just rely on standard parts. It relies on clever engineering that leverages the standard while mitigating its limitations. The practical implications of this approach are staggering. Traditional reactor construction timelines often stretch 5 to 10 years from design to grid connection. Last Energy aims to compress that to a fraction, perhaps 3 years or less. That's an order of magnitude improvement, and if they succeed, it rewrites the nuclear playbook. Other startups chasing custom, bespoke solutions may find themselves permanently behind in both schedule and cost. One of the most fascinating aspects of Last Energy's model is its scalability. Factory-built modular units mean that reactors can be produced en masse once the design is finalized, dramatically lowering cost per unit. Rather than a single bespoke megaproject, they can deliver dozens of smaller, standardized units across multiple sites. It's a classic industrial strategy applied to an industry that has historically resisted mass production. Think Henry Ford meets nuclear energy. And there's a story behind the IKEA-style comparison. Last Energy isn't literally selling reactors in flat packs, but the analogy captures the essence: simplicity, standardization, and ease of assembly. Just like IKEA furniture, each reactor module is designed to fit together reliably with minimal customization. Skilled workers can assemble units efficiently, and maintenance is simplified because parts are familiar, standardized, and widely available. The Series C funding also signals strong confidence from strategic investors. They're not just betting on the concept of modular reactors, they're betting that Last Energy can execute at the industrial scale. This is rare in the nuclear sector, where most investments flow into ideas and prototypes. Capital of this size indicates that investors believe in Last Energy's plan to go beyond demonstration reactors and actually put power on the grid in the near term. Of course, there are hurdles. Even with off-the-shelf parts, nuclear construction is not trivial. Certification, regulatory approvals, and grid interconnection remain complex and time-consuming. Last Energy will have to navigate these processes carefully while maintaining construction speed. But by removing the bottleneck of custom parts, they've eliminated one of the biggest sources of delay in the industry. The result is a much tighter, more predictable timeline. And that's the real story behind Last Energy's $100 million raise. It's not just about money. It's about redefining what's possible in nuclear power development. By challenging the assumption that reactors require entirely bespoke engineering, Last Energy is making the space more agile, more efficient, and ultimately more competitive. Think about the broader implications. If their model works, other companies will have to adapt or fall behind. Supply chains will evolve. Regulators may develop new pathways for approval that favor standardized designs. Utilities may start rethinking procurement strategies, moving from decades-long custom projects to faster, factory-built modular solutions. Last Energy isn't just building reactors. They're potentially reshaping the nuclear energy ecosystem itself. And here's a question for you. When you think about energy innovation, do you imagine breakthrough science or do you imagine operational brilliance? Last Energy is betting on the latter. Sometimes, the fastest path to revolution isn't inventing something entirely new. It's taking what already exists, engineering it cleverly, and executing at unprecedented scale. That's exactly what their $100 million war chest is designed to enable. Of course, skeptics will remain. Scaling modular reactors to real-world deployment is still a massive challenge. Regulatory hurdles can't be bypassed entirely, and integrating multiple units into the grid requires careful planning. But the fact that Last Energy is approaching these problems with proven, standard components and a clear industrial model gives them a realistic shot where many others have failed. The next few years will be critical. As assembly lines ramp up, modules roll off the floor, and sites begin construction, the nuclear community will be watching closely. Success could accelerate the deployment of advanced nuclear energy globally. Failure could remind the world why nuclear is still treated as a high-risk endeavor. But the boldness of their approach cannot be overstated. Using off-the-shelf components isn't just clever, it's potentially transformative. It flips decades of conventional wisdom on its head. The barrier to nuclear scale-up isn't physics, it's the logistics of custom parts. Last Energy is taking that barrier and turning it into an opportunity. So as we watch the company move forward, remember this. The story isn't about a single reactor. It's about a new philosophy of nuclear development, one that prioritizes speed, predictability, and industrial execution. That's what makes Last Energy's $100 million funding round more than just a financial milestone. It's a statement that the nuclear industry may finally have found a path to rapid, practical deployment without sacrificing safety. And here's something to ponder as you think about the future of energy. Sometimes the biggest breakthroughs don't come from the most complicated inventions, but from the smartest way to use what already exists. In the case of Last Energy, off-the-shelf parts aren't a compromise. They're the secret to building a $10 billion reactor faster, safer, and more reliably than anyone thought possible. The question now isn't whether their strategy will work. It's whether the rest of the industry will adapt fast enough to keep up. Last Energy has placed its bet. The clock is ticking, and the nuclear world is watching.